Alrighty, here we go with example number 3. So as you can see, we're back to either monomial or binomial denominators. There's nothing quadratic here, but we still have a little bit of factoring involved, so we can try to figure out the least common denominator. Okay? So there's nothing that I can do with 2x plus 1. There's no GCF, there's no difference of squares, that's factored. 3 is just a single number, but over here there's a GCF involved. Okay? So this is really 2 times 2x plus 1. So now we can see there's a little bit of commonality between the last denominator and the first denominator. Okay, so we want to think about what would that least common denominator be here. All right, so let's go ahead and figure out our LCD. So over here, LCD has to equal. All right, so remember our process for this. We want to go through and we want to look at one denominator at a time and make sure those factors show up in our common denominator. So we're starting with a 2x plus 1 as one factor. Okay, we need to have a 3 in there, and now we need to get a factor of 2. And if you think about the monomials, the 3 and the 2, what's the LCD for 3 and a 2? Those both go into 6. So I'm actually going to erase this 3 and replace it with a 6, okay? Because the 2 will go into the 6, the 3 will go into the 6. The only thing left now is this 2x plus 1, but it's already there. So this is our least common denominator, okay? So now, before we move on, let's say what our domain restrictions are so we know what numbers we're not allowed to have for final answers. Okay? So we're going to have x cannot equal, well, 6 doesn't have a variable in it, so we don't need to worry about that. But right here, we are going to get x equals negative 1/2, and that's a number that we cannot have for a final solution because it would make the original equation undefined. Okay? So now we want to go through and figure out, well, how do I manipulate each fraction so that it becomes this common denominator? And once I have this common denominator everywhere, then I can go through and solve the equation, okay? So I want to go through and identify what changes need to be made. So over here, I need to make this into 6 times 2x plus 1. So what I want to do is just take this whole thing and multiply it by 6. Okay, so that means the top is going to get multiplied by 6, and so is the bottom. Remember, the goal is to make all the bottoms the same, so we don't really even need to write them anymore, okay? Right here, I need to make this 3 into a 6. So I need to multiply it by 2. But it also doesn't have the variable part, the 2x plus 1, so I need to multiply by 2x plus 1 as well. Okay? And then from there, we need to go through and we need to identify, well, how are we going to change this one? This already has a 2x plus 1, but it has a 2 instead of a 6. So that 2 needs to be multiplied by a 3. All right? So again, this is going to create it so that I have all my numerators divided by the LCD, and because we have a common denominator, only the numerators need to be considered, okay? So I'm going to take this first fraction, just focus on the numerator, multiply it by 6. So I have 6 times x plus 2 equals. And now I said I need to multiply this fraction by 2 times 2x plus 1. So I have x times 2 times 2x plus 1 plus, and I said that this fraction just needs to be multiplied by 3, so I take that 3, multiply it by the new 3, so that's going to become a 9. Okay, so this is the equation I want to solve. We're going to do a lot of distributive property to simplify this down, combine our like terms, and then get a game plan from there. Okay, so this is 6x plus 12. This is really 2x, so I'm going to actually tweak this and make it a 2x, so it's a little bit easier to look at. Hold on one moment. Here we go, 2x. So 2x times 2x is 4x squared. This is an equal sign, not a subtract. 2x times 1 is plus 2x. And then I have the plus 9 over here. Okay. So once again, I have a quadratic, and many of these are going to end up being quadratics to solve. So we want to get this to say 0 equals and then solve either by factoring or quadratic formula, whichever one makes the most sense for the equation we end up with. Okay, so subtract these two terms to the other side. So I'm still going to have 4x squared. 2x minus 6x is going to be minus 4x. 9 minus 12 is going to be minus 3. So this is the equation that I want to solve. This is something that you can solve by factoring. If you're not great with factoring when there's a leading coefficient other than 1, then feel free to go ahead and use quadratic formula instead. But I want to remind you that if you start with the a value times the c value, that's negative 12, we will be looking at what are factors of negative 12 that add up to negative 4. And if we go through and think about that, it's going to end up being -6 and +2. And we could replace this and do 0 equals 4x squared minus 6x plus 2x minus 3. And then we could factor by grouping with that 4-term polynomial. Or for those of you that are really proficient with guess and check, then we can just go through and factor this using guess and check. Okay, so I'm not going to finish writing out all of the grouping. Those of you that have been doing this method, you've been doing great with it. I don't think you need me to walk through it. I'm just going to get rid of this. And I'm going to write, okay, this factors into 0 equals. I'm going to need a 2x and a 2x. I need a 1 and a 3. And I need to get a -4 in the middle, so that's going to be negative. This will give me the -6x, and that'll give me the +2x. So I get x is equal to, from the first factor, -1/2. From the second factor, +3/2. And now I just need to check to see if any of those solutions are extraneous. So I go back and I look up here where my LCD is. We said that x cannot equal -1/2, and if you look right here, we got x equals -1/2. So that answer does not actually work. So we get to go ahead and cross it off and say that it is an extraneous solution. So we're going to get rid of x equals -1/2. So you could write it like this and say, I knew it was a possibility, but then I verified that it doesn't work because of this right here. Or you could also just write that your final answer is x equals 3/2. Okay? So you can write it like this and box it in, or you could write x equals 3/2 and box that in. So you can do this as a final answer, or this as a final answer. Either one's fine, as long as you've identified that -1/2 is not a true solution. Okay? That's the end of that one.